Okay, hello everyone. So today I will discuss a sample problem based on the lab activity moment of truth. Okay, so in the moment of truth activity, you were given an unknown mass and you were asked to balance it against the mass of the entire meter stick. Now for meter sticks, okay, where is the mass where is all of the weight going to act? It's always going to act at the center of gravity by definition. Okay? So the weight of the entire meter stick acts at the center of gravity. You also know that the unknown mass has its own weight. Okay? And if you want to figure out the mass exactly, it's just going to be simply weight of the mass is equal to the actual mass times the acceleration due to gravity, or 9.8. Okay? But how exactly do we solve a problem like this? So you know that the weight of the meter stick is at the center of gravity. Let's say that you took it at 0.49 meters and your meter stick is 0.07 kilograms or 70 grams. Here you have an unknown mass. You're trying to look for it, and it is at 0.08. So what does that mean? What does it mean when it's 0.08? It means that you will find it at the 8 centimeter mark. Okay, this one is at the 39 cm mark. This one will be at the 49 cm mark. Okay, so when you have a pivot point here, everything rotates around this area here. Okay, so everything will rotate around that area. Therefore, your moment arm, it's not 8 cm. Okay, it's not 39 cm, but the distance between 39 and 8. This distance over here is your actual D1. That's probably the confusing thing. And this one especially, you are not getting the distance from pivot point to the end. Why? Because the center of mass of your meter stick is actually here at 49. It's not at the end. I know you have some weights at the end, but those are very lightweight. The center of mass of this entire system will still be around this area. So the center of gravity of the entire meter stick is here. The pivot point is here. Therefore, the moment arm of that system, you have a pivot point here. The moment arm of that system, rather, I'll just lengthen it a bit. So pivot point, it's rotating about that area, okay? And this is where the weight is focused, at the center of gravity. So this here is your real D2. Okay, so that's how it actually looks like. Now let's draw it in a real diagram in order to get a better hang of it. So again, let's sketch. Step 1, sketch a simple diagram. So in a simple diagram, all you need is one line, arrows, and the distances. Okay, so to simplify this, okay, we can just draw one simple line. Let's just do it like this. And let's say that you put your pivot somewhere here. Okay? You have the weight of your mass here. You have the weight of your meter stick over here. And you have the distance from pivot to the center of gravity, and also the distance from the mass to the pivot. Okay, that's the diagram. That's it. So, what are the values? So we know we're looking for Wm. So next step would be G and R. Wm, you don't know, but you know it's equal to mass times gravity, 9.8. Okay? Weight of the meter stick, you know, is equal to 0.07 kilograms times gravity, 9.8 meters per second squared. So this should be in newtons. And if I plug that into the calculator, what do I get? So that's 0.07 times 9.8 gives me a value of 6.86 newtons. Okay? And the key thing here is to be exact as possible. Do not use sig fig answers just yet until the very end. Okay? That's the weight of the meter stick. What is the distance number 1? distance number 1 is from your mass to the pivot point. Here, your mass is at 8 meters, 0.08 meters, or 8 cm. And here, it's at 39. Therefore, if you want to get D1, it's 39 minus 8. So D1 is 39 cm, but 39 cm is obviously 0.39 meters if you convert it, minus 0.08 meters. That should give me a value of 0.39 minus 0.08 is equal to 0.31 meters. Okay? And what's D2? D2 is simply going to be pivot point to the center of gravity. Where's the center of gravity? It's at 0.49 meters. 0.49 meters. Where's the pivot point? 0.39 meters. And what do you get if you subtract that? I know I could probably solve this mentally, but let me just plug it in so you know that I'm solving it exactly. 0.1 meters. Okay? So those are your unknowns and your givens. Now we solve. What equation do we use? There's only one equation to use here. Moments is equal to 0 is equal to moments counterclockwise, which is positive, plus the moments clockwise, which is negative. Okay? So you know that 0 is equal to the moments counterclockwise. Which moment is going counterclockwise here? Well, if you can use this kind of guide. So which is going counterclockwise? I think it's the weight of the mass. Why? You go this way, that's the distance, and then the force kind of goes in that general direction. Okay? Go that way, go down like this, so you have counterclockwise moment. So that's simply the weight of the mass times the distance number 1. Distance 1 is given as 0.31 meters. Okay? Now, what is the clockwise moment? Again, go this way from the pivot point, force goes down, goes clockwise. So, that's going to be negative because it's clockwise. What's the weight of the meter stick? The weight of the meter stick is equal to 0.686 newtons. And what is the distance number 2? Distance number 2 we've solved is equal to 0.1 meters. Okay, so now our objective here is to then solve for this. And to get that, we can just simply put this on the other side. So that's simply 0.686 times 0.10 all over 0.31 gives me the weight of the mass. Okay, so if I plug that into the calculator, it's 0.686 times 0.1 all over 0.31 gives me 0.22129 Newton meters, or rather newtons. Sorry, it's weight after all. So that's, again, 0.22129. Be as exact as possible. Newtons. But how exactly do we get the mass? Let's go back. Weight of mass is equal to m times g. So this is also equal to the actual mass that we're looking for times g, which is 9.8 meters per second squared. Let's use the units. So the mass, if you use SI units, it should be in kilograms. That's why it's important to always make sure you're in SI units. Always use kilograms, always use meters, always use newtons, always use seconds. Okay, SI units. So that's simply, let's rearrange it first before we plug it into the calculator. M is equal to 0.22129 all over 9.8. Okay, so let's use this one. And to be as exact as possible, I'm going to click this button here, ANS, so that that comes up. And we know that we have to divide this answer by 9.8 meters per second squared, which will give me a value of 0.22129 0.2258. So that's your mass. 0.2258. Okay, 0.002258, and because you use SI units, kilograms. Okay, so that's how we solve for the unknown mass. We have to be as exact as possible until the very end when we can finally apply significant figures. Now, what is there for significant figures? Well, according to this, we only actually used one significant figure. So, this is going to be around, simply, 0.02 kilograms. That's the mass of the unknown object. If you put this in, this will be around 20 grams. And this would actually be a really good calculation for one of the wooden blocks in our experiment. Okay, so that's in general how we solve for an unknown mass such as this. If you have any more questions, please feel free to ask it in this video. If not, I hope that this video was able to enlighten you about the process of solving a problem like the one in the laboratory challenge. So take care everyone, and have a good night.